At 5,066 years old, the oldest individual tree in the world was already close to 700 years old before the date of their flood. And that's not all. This Norwegian spruce in Sweden is a clone. The trunk that is growing there now may only be a couple centuries old, but the genetically identical material from the root system that sprouted it and others before it was carbon dated at 9,558 years old. And it doesn't show record of a global flood either. And that's still not all. There are a number of other clonal organisms that scientists have determined by combining dendrochronology with radiocarbon dating or various other means to be extremely old, like these yuccas and creosote bushes at 12,000 years old each. These leaves on the ground are really the top of a clonal tree that lived entirely underground for 13,000 years. The Pando is a forest of 47,000 genetically identical clones, all emerging from an interconnected root system that is essentially a single male aspen tree, estimated to be at least 80,000 years old. And there are other clonal organisms even older than that. But let's forget about estimates with uncertainties and focus on what we know absolutely. Let's not forget about individual trees and the fact that other species besides bristlecones have been shown to have overlapping sequences of matching rings. The longest continuous tree ring chronology so far is a series of oak and pine sequences spanning 12,460 years before present. That's several generations of trees living through normal conditions, covering the entire Holocene and part of the Pleistocene well into the Ice Age, with, again, no hint of a global flood. Not even in those times where we know that some of the biggest floods in history have actually happened. They just didn't affect this part of Northern Europe. And that's not even mentioning fossil trees, like Arizona's petrified forest. Those trees are so old that their rings can't be correlated with any living trees. But fossil trees can be correlated to each other, as we see in Yellowstone National Park's Specimen Ridge. Here we find evidence of 27 forests. Not 27 trees, 27 forests preserved in volcanic sediment, with each forest being buried on top of another. How is this possible? Observing present-day volcanoes and their effect on the environment, now we can make sense of this. Starting with the first, in Consaqua, the bottommost forest, we find a volcano erupting in what was called the Eocene epoch. The animals flee this eruption, thus leaving very few of their fossils, but the trees, unable to do anything but stand firmly in their spots, are buried by the volcanic eruption. However, they're not completely buried. Any trunks or branches not covered in ash will rot, preserving only the parts that are covered.